Next, experimental methods to study overall deformation process causing chip formation. Okay, so there are three experimental methods: study of deformation of rectangular or circular grids marked on the side surface, then microscopic study of chips frozen by a drop tool or quick stop operators, study of running chips by high speed camera fitted with low magnification microscope. By these three methods, so we can study the formation of chips. Okay. So first one, that is by considering rectangular grids and circular grids. So here this is the grids on the material. Okay, this is the work material. Here you can see. You must be able to identify, or you must see the difference between the shape of the grids, uncut layer of the material and the chip. Okay, this is material which is removed in the form of chip. Okay, so you can see the shape of these grids. Okay, so earlier, so these grids are having rectangular shape. After deformation, so you can see they are having the shape of rhombus. Okay, so because of this, so you are having larger thickness for the chip compared to uncut layer of the material. Okay, so next, if you consider circular grids, so initially, so grids are having circular shape, same grid. Okay, in the deform in chips. Okay, it is deformed to take the shape of ellipse. Okay, because of that reason, so you are having so larger thickness compared to the uncut layer of the work material. Okay, this is one method. Next, so there's another method, that is microscopic study. Okay, in microscopic study, so machining will be performed at a velocity vc. Okay, so suddenly machining will be stopped and tool will be taken back, and later the chip will be removed and it will be taken for studying purpose. Okay, in microscopic study of frozen chip method, the machining needs to be suddenly stopped at high speed. So you are not gradually stopping it. So you are not reducing the velocity and then you are stopping. So immediately you are stopping the machining process. Okay. So in microscopic study of frozen chip method, the machining needs to be suddenly stopped at high speed to obtain frozen chip under machining at normal speed and speed for close study of mechanism of chip formation and chip tool interaction. Okay, that means so you are suddenly stopping the machining operation, or you are suddenly stopping the machine. Okay, so then the cutting tool is rapidly withdrawn. So that means suddenly, quickly you are withdrawing the cutting tool. The cutting tool is rapidly withdrawn at velocity higher than VC to retain the chip intact as indicated in figure. So that means you are taking this cutting tool back. So at a velocity, so the velocity of taking this tool back will be greater than the cutting velocity. That is denoted here. Okay, later, so this chip will be taken for microscopic study. Okay, so after stopping the tool work motions, the portion of the frozen chip is cut out and then mounted and polished for study under optical as well as scanning electron microscope. Okay, so this will be taken and it will be further studied. Okay, so next, chip formation in machining brittle materials. Okay, so if you have any doubt, you can ask, or otherwise I will continue with this topic. Okay, so this is the last topic which I am going to cover in this session: chip formation in machining brittle materials. Okay, in the previous session we discussed about ductile and brittle materials. Okay, examples also we considered. Okay, so which are the examples for brittle materials? ಯಾವ್ದು brittle materials ಅಂದ್ರೆ cast iron. Okay, so in case of examples for ductile materials are mild steel, copper, aluminum. Okay, So already we discussed about chip formation in machining ductile materials. So in case of ductile materials, so you saw formation of continuous chips, okay. Whereas in case of brittle materials, so it is not possible to get continuous chips, okay. You are able to get the broken chips. During machining, first a small crack develops at the tool chip due to wedging action of the cutting edge. So what do you mean by wedging action during machining? So here also you are performing machining. First a small crack, here you can see a small crack will be developed here. A small crack developed at the tool chip due to wedging action of the cutting edge. What do you mean by wedging action? So wedging action is due to the contact between two surfaces, okay. So surface of the tool and the work material. So because of this contact, okay, there will be wedging action, okay. So and because of this wedging action, there will be formation of crack at this region, okay. So at the sharp crack tip, stress concentration takes place, okay, stress concentrate. So and later this crack will propagate, material will be removed in the form of broken chip. The initiated crack, this is the initiated crack, quickly propagates, that means it proceeds, quickly propagates under stressing action, and total separation takes place from the parent workpiece through the minimum resistance path. So this is the minimum resistance path, so through which so crack will propagate, and that will result in complete separation. So that means complete separation means, so here you are not able to get the continuous chip, whereas in case of ductile materials, so there will be separation, but before complete separation takes place, the chip is going to move further because of no stress, okay. So complete separation was not taking place, okay. Whereas in case of brittle material, this crack will propagate quickly and it will break, okay. So it will result in complete separation. That is the difference, okay. So here you can see how chips are formed in case of brittle materials. So machining of brittle material produces discontinuous chips, that means broken chips, and mostly of irregular size and shape. Okay, initially there will be a crack, and that crack will proceeds, and that will result in complete separation. So this is a chip, broken chip, okay. So then during okay, when the crack proceeds, okay, that stage we call it as swelling. So this crack will propagate in the minimum resistance path, so that is called as swelling. Further swelling means again it is proceeding, okay. So later there will be separation. Okay, so again after one layer of the material is removed in the form of chips, further material will advance, okay, and again so same process will be repeat for this layer, okay. Again it will be removed, again material will further proceed like that. So material will be removed in the form of broken chips in case of brittle materials.